Welcome, Internet viewers. My name is Cheryl Zimmerman. I'm the CEO of FarSounder. The objective of this presentation is to demonstrate how forward-looking sonar can be an important navigation tool for the 21st century. We will be exploring the challenges of safe navigation, just what is forward-looking sonar, and how it can be used to help make navigation safer. As more and more vessels operate in more and more challenging environments, the risk of collision increases. These risks arise from poorly charted or wrongly placed obstacles and transient objects such as shipping containers. Arctic waters are particularly challenging. Cruise ship Explorer was the first cruise ship to bring passengers to Antarctica and also the first one to sink. You are all familiar with simple sonars such as echo sounders. They point straight down but tell you nothing of the obstacle ahead of you. If these basic sonars are simply pointed forward, you could call it a forward-looking sonar. However, a single narrow beam still tells you nothing about the rock below or the floating hazard ahead of you. Some simple forward-looking sonars even spin around like an underwater radar. Unfortunately, sound travels much slower in water than radar signals do in air. This results in a very slow update rate that is not useful for navigation. To be an effective navigation tool, a forward-looking sonar must have a wide field of view and be capable of sensing from the sea floor all the way to the sea surface with a single ping. Everyone is familiar with navigation tools. Radar looks above the water. Charts show you what was there the last time someone looked, if someone ever looked. Forward-looking sonar fills in the most basic information. What is underwater in front of your ship before you get there? Let's now take a look at important metrics to consider when evaluating forward-looking sonar systems. The first is the 3D capability. 3D capability means the system is capable of determining range, bearing, and depth with a single ping. This slide compares traditional two-dimensional processing with FarSounder's three-dimensional processing with a single sonar ping of a pier wall. On the left is the traditional 2D sonar image. Color is mapped to reflection strength, where red is loud and blue is quiet. You can clearly see the reflections corresponding to the pier wall, but there are also some other loud reflections. Is it safe ahead? On the right are examples of this same ping processing in 3D. Color now corresponds to depth. The pier wall is shown in red as it comes up to the water surface. The seafloor is blue, deep, and safe. The next metric to consider is the coverage zone. To be effective, a forward-looking sonar must be able to cover a long range, a wide field of view, and to also provide depth. In order to make quick decisions, the sonar must have a fast update rate. This means that the entire coverage zone should be updated with a single ping. Mechanically scanned sonars, which build an image from multiple pings, take too long to be useful as a real-time navigation solution. Most importantly, the image the sonar displays should be easy to understand for the operator. Chart overlay of in-water targets enables the operator to quickly correlate what the sonar shows with the situation at hand. The last metric I want to discuss is range. This metric is more complicated and can be split into two parts. The first is maximum detection range of an in-water target. The other is how far ahead can the bottom be mapped. Maximum detection range is a function of each sonar specification. Bottom mapping range is a function of the depth of the water below the sonar. Let's take a moment to understand the bottom mapping limitation. When sound energy is transmitted down at a steep angle, most of that energy reflects back to the sonar. As the transmission angle becomes more shallow, some of the sound energy reflects back to the sonar and some of it reflects forward. Eventually, as the angle gets very shallow, all the sound energy reflects forward. This is your bottom mapping limit. After the bottom mapping limit, the sound waves continue to propagate forward, bouncing off both the sea floor and the sea surface. Still, these sound waves will reflect off of a large target on the sea floor, those in the water column, and also at the sea surface. These are all detected as in-water targets. So what makes a good sonar great? I believe a great forward-looking sonar should create a true 3D image which is stable from ping to ping and also be easy to interpret. Now that we've discussed important metrics to consider, let's take a quick look at some case studies. By adding together the time for the sonar to reliably detect an obstacle, the time to alert the operator, the time for the operator to make a decision, and also the time to maneuver, a little simple math can be used to calculate the minimum sonar range needed. A detailed discussion of this math can be found on the tech blog of our website. In our first case study, let's consider a trawler or yacht. For a 40-meter vessel traveling at 12 knots, a minimum detection range of 380 meters is required. In this next case study, let's consider a much larger vessel. For a 100-meter vessel traveling at 13 knots, 870 meters can be calculated at the required sonar detection range. We've talked a lot about theoretical topics. Now let's take a look at FarSounder's navigation sonars, which can meet many vessels' needs today. Our FarSounder 500 offers a 90-degree field of view out to 500 meters maximum range. This is about a 1/4 nautical mile. Our FarSounder 1000 offers similar capabilities, as well as a 60-degree field of view out to 1,000 meters maximum range. This is over a 1/2 nautical mile. Our sonars have been installed on numerous ice-hardened bulbs, both new builds and refits. However, a large bulb is not required. Here are some examples of our sonars installed on various raked bows. Again, this can be done with both new builds and refits. Our sonars have also been installed on smaller expedition-style hulls. Though most of our customers prefer a simple fixed installation, some customers have chosen to install the sonar on a retractable hydraulic hoist. Even today, forward-looking sonar is not yet required by the Coast Guard, IMO, or insurance companies. However, the safety advantages of forward-looking sonar is a no-brainer for the 21st century navigator. FarSounder's products are already in use in the Arctic and Antarctic regions. They've transited through the Northwest Passage and are in use on all sorts of commercial, passenger, and private vessels. I hope that this quick overview of forward-looking sonar has been helpful for you. The FarSounder team hopes you'll consider one of our products for your vessel and wish you a safe journey. Please visit our website to read more about our technology and learn more about our products.